So good day, wherever place you are watching from and whatever time you are watching from. This is a YouTube tutorial video organized by the Academic Unit of the Celestial Church of Christ in Parish Futa. And today we'll be taking MTS 104, the second section, which is application of vector. As I do say from our previous tutorials, we'll be tailoring this teaching to Futa curriculum. So there are some exercises or some things we might not be discussing. But believe you me, we'll be taking it the way it should be, and that will help you connect to the Futa curriculum. So let's get to work. In the first section, we talk about vector, we define vectors, and we give some exercises and some explanation. In the second section, we'll be looking at the application of vectors, that is the usage of vector. And in this section, what was discussed majorly was about the scalar multiplication and the vector multiplication. So just remember scalar multiplication, vector multiplication, and let's take it one at a go. So we have the scalar product, which is also known as the dot product, denoted by the symbol dot. And this is the multiplication you are well aware of, where you have 2 times 3. So in vectors, we don't represent this as that times you know of. That times you know of, 2 times 3 will give you 6. But in vector, it doesn't mean 2 times 3. This is what you use to denote that kind of multiplication, 2.3. So that gives you 6. So there is a rule that goes in vector that when you have a dot product, A dot B, it gives you, it's equals to the modulus of A. The modulus of B equals theta. I remember we discussed modulus of a vector or the magnitude of a vector as the square root of the squares of its ijk component. So A dot B equals to modulus A modulus B equals theta. Now there's something you should note now, but I will explain further when we do that. If A and B, if your vector A and your vector B, let's call these 2i minus 3j for example. If these two are parallel, your scalar product would be 0. If these two are parallel, it means they are the same thing. If they are perpendicular, it means your dot product will give you 0. Probably don't let that bore you. Just note this, that this is your I and this is your j. Your I dot your I will give you 1 because they are parallel. Your I dot your j is still the same thing as your j dot your I, they will give you 0, and your j dot your j would give you 1. So note this, since they are parallel, the product gives you 1. Since they are perpendicular, the product gives you 0. No, cos 0 gives you 1. Cos 90 gives you 0. So let's go. How do you multiply using the scalar product? Let's assume you have a vector A to be 2i plus 3j and your vector B to be 4i minus 3j plus 2a. Now let's start with the 2-dimensional vector. Then you want to find the scalar product of this. You have 2i plus 3j into brackets and this 4i minus 3j into brackets. So let's use the long method of multiplication first. Then I show you how to multiply this in a very short way. Using this normal, that is 2 takes this takes this. You have 2 times 4, 8i dot I minus 6i dot j plus 12i dot j or j dot I. Minus plus and minus 3 times 3 9j dot j. Recall that I dot I gives you 1, I dot j equals to j dot I equals to 0. So I dot I is 1, 8 times 1, that is 8 in the bracket 1 minus I dot j is 0 plus 12 j dot I 0 minus 9 j dot j 1. You should have 8 minus 0 plus 0 minus the 9. 8 minus 9 should give you minus 1. So do you see this is a long method? So whatever time you have A dot B, what you need to do is just pick your I component and your JJ component, because your IJ component will definitely give to 0. So next time when you have 2i plus a 3j plus 4i minus 3j, what you should do is 2 times 4, 8. No, just say 2, 4 plus times minus 3, 3. So it should be 8 minus 9 minus 1. So look at this. Definitely you should prefer this. So this is A dot B. And this is how you solve it. What if you have a 3-dimensional component? Let's say is I minus 2j plus k. Then you have B to be 3i plus k. Do not forget that you not giving j doesn't mean j is in there. This is a 3-dimensional component. They're just giving something, but it's 3-dimensional. So what you need to do is A dot B is I minus 2j plus k 3i. You can add your j component 0j plus 2k because it isn't there, so it is 0. So you should have 1 times 3 plus times minus minus 2 0 plus times plus plus 1k and 2k. So you should have 3 minus 0 plus 2, that is 3 plus 2, and that should be 5. Are we good to go? Now the next thing we want to do is the application of this scalar product. How do you apply the dot product? So one of the importance of dot product is that you can use, okay, not the importance actually, one of an exercise you can be given is to get the angle between them. To get the angle between them, or to determine the relationship between the two vectors. Okay, so let me explain that using this. We use this dot product, the same thing with vector products. You can use those products, to get the relationship between those vectors. But the application of it is to get the areas of shapes, like the area of a triangle, area of a rectangle, provided you are given those sides in vector format. Now let's assume you have A equals to I plus 2j, and you have B equals to 2I plus 4j. Let's look at the conditions for parallelism. If they are parallel, you have A dot B should be modulus of this cos theta. A dot B equals to parallel. When two lines are parallel, there is no angle between them. The angle between them is 0 because they are sleeping. So you have cos theta. So A dot B equals to times cos 0. So cos 0 gives you 1. So this is the condition for parallelism. So if you have two vectors, to know if they are parallel, their product, their scalar product should be the same thing as the product of their modulus. So let's assume we are given a question that you have vector A and B. Are these two vectors parallel? How do you know if they are parallel? Find A dot B. A dot B should be 1 plus 2j times 2I plus 4j. So this is the condition. This is how you know 1 times 2, right? That is 1, 2, plus times plus, plus 2 and 4. The short way to scalar product. So you have 2 plus 8, and that is 10. Now let's get the modulus of A. The modulus of A is square root of I, that is 1 square plus 2 square. That is square root of 1 plus 4, and that is square root of 5. For B, the modulus is 2 square plus 4 square. That gives you 4 plus 16, that is square root of 20. So by the time you get the product of the modulus, this modulus A modulus B gives you square root 5 times square root 20. You should have square root 5 times 20, and that should be square root of 100, and square root of 100 should be 10. Now look at your A dot B, it's 10. Look at your is as well 10. So add it being what you have. If your A dot B is not equals to this, then you say not parallel. The two are in parallel. But since they are equal, if you have it this way, it is not parallel. But since they are equal, so it means the two lines are parallel. So do we get this? Now the same goes for perpendicularity. So what is the condition for perpendicularity? If you want to know if two vectors are perpendicular, so for perpendicularity now, perpendicular vectors, if you want to know if two vectors are perpendicular, A dot B, this is what we mean by perpendicular. So the angle between them is a right angle, that is 90 degrees. Now let's impute that into this formula. You have A dot B equals to modulus of A modulus of B cos 90. And if you check from your calculator, cos 90 should be 0. So A dot B equals to modulus of A modulus of B times 0. And this 0 will definitely make everything here 0. So for your perpendicularity, to know if two vectors are perpendicular, their scalar product has to give you 0. An example of such vector is this. Let's look at vector A equals to 4I plus 3j, and vector B equals to 3I plus 4j minus 3I plus 4j. So let's look at these two vectors and let's see if they are perpendicular or not. So to get if these two vectors are perpendicular, this is what we want to achieve. Their scalar product should be, we don't even need to look for the magnitude, just their scalar product should be equal to 0. So or let's change it to no need of changing it, let's just use A and B. So A dot B should be equal to 0 for perpendicularity. This is a condition for perpendicularity. So what is A? That is 4I plus 3j multiplied by minus 3i plus 4j. Then we have 4 into bracket minus 3 plus 3 into bracket 4. That is minus 12 plus 12. So you can see that a dot b gave us 0. So this way shows that it's perpendicular. If it didn't give us 0, it's not perpendicular. Now, it is not every time you have parallel or perpendicular, condition. There are sometimes when you might be asked to get the angle between them. So it's just still the same thing. A dot b equals to this cos theta. So the angle between them might be 30, might be 60, might be 100, might be not 100, and any degree. So how do you get it? Let's assume the question says find the angle between. Some questions would help you and say find the cosine of the angle between. Yeah, find the angle between the vector below. Let's say the vector below. So the vector, let's pick A to be 2i plus, or let me just put it in this format, 2, 1, 1, and B 1, 1, 1. So it means A equals to 2i plus j plus k, B equals to I plus j plus k. So for me to get the angle from this formula, cos theta equals to A dot B over magnitude of A, magnitude of B. So A dot B, let's do it quickly, 2, 1, 1, 1, 1, 1. You remember dot product, right? For the magnitude now, 2 square plus 1 square plus 1 square. The modulus of this other one, 1 square plus 1 square plus 1 square. So you should have 2 plus 1 plus 1. This is cos theta, do not forget. So 2 square, 4 plus 1, 5, 5 plus 1, that should be 6. Square root 6. 1 plus 1 plus 1, that should be square root 3. So you should have 4 over square root of 18. And that should be 4 over square root of 18 is square root 9 times 2. So cos theta should be 4 over 3 square root 2. So then if you are looking for the angle, what do you do next? If you are looking for the angle, what do you do next? Just come here and say theta equals to arc cos 4 over 3 root 2. So when you find 4 over 3 root 2, then you find the shift cos on calculator, then you get your answer. So that is that. Are we good to go? Now, another thing I would like us to to quickly talk about is the application. The course itself is the application. I told you the other time that one of what you can use dot product is to get the areas of shape, a triangle, a rectangle, and co. So the question might ask you that calculate the area of a triangle. Like a question in the exercise in the manual. That was question number 12. So the question says if u equals to I plus 12j plus 3k, I plus 2j rather, v equals to 2i plus 3j plus 4k, represent the size of the triangle. So find the area of the triangle. The area of the triangle is a b cos theta. So what do you need to do? Just know that a b cos theta is same thing as a dot b. So get the a dot b. 2 plus 6 plus 12. 2 plus 6, 8 plus 12, 20. So that is 20 square units. So that's one of the applications. Now we'll be going to the linear dependent then. Linearly dependent and linearly independent. So if the question says is two vectors linearly dependent or not, so what do you need to do? Linearly dependent or not, it means is a vector a scalar product of the other one. Linearly dependent. If it is a scalar product of the other one, it's linearly dependent. What I'm saying is, let's say you have 2i plus 4j. You can see that this is 2 times of I plus 2j. So these two vectors, 2i plus 4j and I plus 2j, they are linearly dependent. So let's assume I have 3i plus 6j, and I have 4i plus 2j. Are they linearly dependent? You know that 3 times what will give me 4? 3 times 4 over 3. to give me 4. With 6 times 4 over 3 give me. So there's nothing I can multiply this with to get here. But a simple way to do that is this. If two terms are linearly dependent, the determinant of the matrix, let's assume UV. We have vector U and V. If they are dependent, the determinant of the two will be equal to 0 for linearly dependent. If the determinant isn't equal to 0, it is linearly independent. They are not dependent on themselves. So linearly independent. So this is it. Let's assume the former question I gave you 2i plus 4j and I plus 2j. How do I know if they are linearly independent? 2i plus 4j and I plus 2j. To get if they are linearly dependent or not, what you need to do is just find the determinant of the two. I1, 2j 2, 2i 2, 4j 4. Put it in the matrix. There you go. Multiply 1 times 4, then 2 times 2. You know in matrix, this is the leading diagonal, these two, then this is the diagonal that follows. So 4 minus 4, you can see it is 0. It's linearly dependent. And you can see the other factor we're talking about. It is the scalar product of the other one. Are we good to go? Now let's look at another one. Let's assume you have a 3 by 3 matrix. Let's assume you have 2 1 1 and 1 1 1. So are they linearly dependent? That is what we want to get. Are they linearly dependent? The best way to get this, or the easiest way, just use your matrix. So draw, get the matrix, a combined matrix for these two. 1 1 1, 1 for I, 1 1. Okay, let's pick a question from the textbook. The question says, get if this 1 2 1. So the question 1 2 1, 1 0 minus 1. 1 0 minus 1. These are 3 vectors, and the last one is 1 1 1. So let's get if they are linearly dependent or not. So 1 2 1 ijk, 1 0 minus 1 ijk, 1 1 1 ijk. So what do you need to do? You put plus here, you put minus here, you put plus here. You should remember determinant. Then you pick this one, then you do the minus now. So when you close this and you close this, it remains 0 minus 1 1 and 1. When you pick minus 2, when you close the row of minus 2 downward and you close the column, so what can you see now? You have just 1 minus 1. So this is what I'm doing. If I close this, I have 1, so minus 2, 1 minus 1 1 1. Why is there a negative here? That's the rule of getting determinant in the matrix. You put plus minus plus. This next one will be minus plus minus plus minus if you need them, but you don't need them, just need the top row. So the next thing is plus 1. A plus 1, so minus 2, 1 minus 1 1 1. So let's do for plus 1 as well. So plus 1, if you close plus 1 and this one, so you have just this one. So let's assume it is plus 1. We are striking out 1 2 1 1 1 0 1. So if it is this plus 1, we strike it down and you cross here too. So you have 1 0 1 1. Now let's go. Then you go back to 2 by 2 minus 0 times 1. 0 times 1 0 minus 1 times minus 1 minus 1. Minus 2. 1 times 1 1 minus 1 times minus 1 minus 1. Let me line this please. Then you have plus 1. 1 times 1 1 minus 1 times 0 0. So you have 1 0 plus 1 1 minus 2. 1 plus 1 2 plus 1 1 minus 1 1. So you should have 1 minus 4 plus 1, that is minus 3 plus 1, that is a minus 2. Since it is not equal to 0, these 3 matrices are linearly independent. They are linearly independent since it is not equal to 0. Okay. Now let's take the cross product. We call it the cross product or the vector product. That is scalar product. So the cross product that uses the sign, this sign cross, or the name cross product. So A dot B, A cross B, it has the formula A B sine. Let's call it sine theta. Then there's a unit vector here, where you can leave this out of it for now. So, but in its own sense, you have to have its modulus. So this is for that law, and everything we said for scalar products, still applies here. Meaning there is a time where you can get if they are parallel, you can get if they are perpendicular, you can get, but this is the law. If they are parallel, the angle between them is 0. Sine 0 gives you 0. So this is the condition for parallelism. If they are parallel, that is, if you want to use vector product to decide to know if two vectors are parallel, their cross product, the modulus of their cross product has to be 0. If they are perpendicular, it means the angle between them is 90 degrees. They are not watch the cross product, the scalar product. It might be hard getting this. So if it is perpendicular, it means angle 90 exists. The sine 90 is 1. So this is for perpendicular. They are perpendicular. And if you want to get the angle between, that is arc sine A cross B modulus over. So everything we did in scalar product, but you see that it is the opposite. In scalar product, this is the condition for parallelism. This is the condition for perpendicularism. It's opposite because it is sine we are using here. Sine 90 is 0, is 1 here. Cos 90 is 1 on its own. And cos 90 is 0 for scalar. Sine 90 is 1. So that's why they interchange. Now let's go. How do you get A cross B? And I given A cross B, how do you solve for A cross B? So this is it. If you have A equals to I minus 2j plus 3k, B equals to I plus j minus 2k. So how do I get A cross B? So to get A cross B, we've done that earlier on. Your A cross B is basically, your matrix, putting ijk, then go 1 minus 2, 3, 1, 1 minus 2. Then you solve this. So for I, cross it. So circle this. You should have minus 2, 3, 1 minus 2. For j, that will be minus j. We have plus, minus, plus. So for j, you should have minus j. Circle this. 1, 3, 1 minus 2. For k, you should, if you cross this now, you should have 1 minus 2, 1, 1. So eventually you have I minus 2 times minus 2, that is 4, minus 3 times 1, 3, minus j, 1 times minus 2, minus 2, minus 1 times 3, 3, plus k, 1 times 1, 1, minus 1 times minus 2, minus 2. So you should have I 1 minus j minus 5 plus k 1 plus 2, that is 1i plus 5j plus 3k. You can see unlike scalar product where we have a value as an answer. In cross product, you don't have a value as the answer. You get, so you have a vector as your answer. So what we do in this sense now is that we have to get the magnitude of it. So let's assume I want to get the angle between these two. So to get the angle, let's assume I want to get angle between AB, angle between vector A and B, for instance. So what do I need to do? I'll say magnitude of this equals to scalar of this is sine theta. So I've gotten this already, but I need to get the magnitude. That will be square root. That will be square root of 1 square plus 5 square plus 3 square equals to, for A, 1 square plus minus 2 square plus 3 square, times the square root of, for B2, 1 square plus 1 square plus minus 2 square, then I have the sine theta there. So 1 square should be 1 plus 25, 26 plus 9, that's 34. 26 plus 9, that is 35. Then I should have square root 1 plus 4 plus 9, that is 14. Then I should have 1 plus 1 plus 4, that is square root of 6. Then I should have sine theta. So here I'm having square root 35 equals to square root 64 sine theta. So to get the angle, between them, so sine theta equals to square root 35 over square root 64. So when you get this, your theta will be arc sine whatever you get, that is 35 over 64. Then you're good to go. So if it is for parallel as well, you should know that once you get if it is for parallelism, let's say the condition for parallelism, once you do your A dot B, it should give you 0. then you know A and B is parallel. If it is perpendicular, once you get your A dot B modulus, the answer should be same thing as A modulus and B modulus for perpendicularism, for parallelism. So that is it on scalar product and vector product. There are a lot of questions you can practice on this. Take a tutorial manual, go through them over and over again. You can go through the video again if there is a part you didn't get. So wish you the best, and may the Lord grant you strength and understanding. Take care.